All right, welcome to the Unit 3 review key. We're going to go through the 4 problems. Ideally, you would try these problems on your own first and then check the review key if you get stuck or to verify your answer. I think that's how you'll get the most bang out of your buck for it and be able to get as high a score as you would like on the AP test. Our first question. Let f be the function defined by f of x is 1 plus tangent of x to the 3 over 2 power. We need to write an equation tangent for the line tangent to the graph. So to do this problem, we need to write a tangent line. How do you write a tangent line? Well, you need to know two things. You need to know slope and a point. So to find slope, we take the derivative. To find the point, well, they give us x is 0, so they give us the x value of our point is going to be 0, but they don't give us the y value. So we can find that y value really quick if we want to do that first by plugging in 0 to our function. So f of 0 would be 1, our quantity 1 plus tangent of 0 to the 3/2 power. But tangent of 0 is just 0, right? If you think on a unit circle here, at 0 degrees, your coordinate is 1, 0, and tangent of an angle is y over x. Oop, y over x. And so 0 divided by 1 is just 0. So this is 1 plus 0, which is 1, to the 3/2 power is just 1. So our point is going to be 0, 1. To find the slope, again, we take the derivative. So to take the derivative of this function is going to be the chain rule, because we have two functions here. We've got this inside function, 1 plus tangent of x, that's being raised to the power of 3/2. So we have to deal with the outside first. To take the derivative of this quantity to the 3/2 power, I use the power rule. I take the power and I move it out in front, leave the inside the same, and then I subtract 1 from the power. 3/2 minus 1 is 1/2. And then I'm going to multiply that by the derivative of the inside function. The derivative of 1 is 0. The derivative of tangent is secant squared. So my derivative is 3/2 times 1 plus tangent of x to the 1/2 power times secant squared. To find the slope at 0, again, we're going to plug in 0. So f prime of 0 would be 3/2 1 plus tangent of 0 to the 1/2 power times secant squared at 0. Well, tangent of 0 again is just 0. Secant squared is going to be 1, because again, secant is going to be the secant, I switched to the secant of an angle. Secant of an angle is r over x. The radius at the unit circle at 0 is 1. The x value is 1. 1 divided by 1 is 1. So this is 1 squared. So this is going to be 3/2 times 1 to the 1/2 power times 1 squared, which is just 3/2. So our slope is going to be 3/2. So then we could write our equation as, in slope form, you use this style of writing your equation. Again, our y value we got was 1. Our slope is 3/2. And the x value they gave us is 0. So then this is the equation of a tangent line to that function at x equals 0. This problem was worth 5 points. 5 points. 1 point for you getting that f of 0 is 1. So if the only thing you knew was you need slope at a point, I need to find the point, which means I need to find the y value, you would have gotten 1 point for writing this work right here and telling me that the point when x is 0 is y equals 1. 2 points for getting the derivative, so you would have gotten 2 points for correctly doing the power rule and the chain rule here, and then 1 point for finding that f prime of 0 is uh, 3/2, and then you would have gotten your last point for writing your equation. So you would have gotten 2 points for our derivative, 1 point for plugging 0 into that derivative and getting the answer 3/2, and then 1 point for then writing your equation of the form y minus 1 equals 3/2 x minus 0. All right. Number 2. For number 2, we're asked to consider this curve and write an expression for the slope. So this part is even like, at least directions wise, is easier than the other problem. All we are asked to do is write the equation that gives us the slope. And again, how do we find slope? Uh, we slope, sorry, at different points. We find slope at different points by take the derivative. So basically, what this question is asking us is, what is the derivative of this expression? The derivative of this expression requires you to do implicit differentiation. If I want to take the derivative with respect to x of x squared plus xy plus y squared equals 27. All of these are with respect to x, but we have y values in our function, so that's why we have to use implicit differentiation and keep track of what happens when we take the derivative of those values. So let's just work left to right through this derivative. The derivative of x squared is the power rule. I take the power 2, move it out in front, subtract 1, it becomes 2x to the first. To take the derivative of xy, you have to do the product rule because that's x times y. As a reminder, the derivative of two things multiplied together is uv prime plus u prime v. The derivative of the second times the first plus the derivative of the first times the second. So for this one, we'll do plus x times the derivative of y. And the derivative of y with respect to x is dy dx. Okay, because we're not taking the derivative of y, the derivative with respect to y, we're taking the derivative with respect to x. That is going to be plus u prime v. So the derivative of x is just 1, and then you could write dx over dx, but dx over dx, again, is just 1. It cancels out. Times y plus, okay, for this one, you have to do the chain rule. So you're going to take that 2, move it out in front, becomes 2y to the first times the derivative of y, and the derivative of y is dy dx. That's going to equal the derivative of 27. 27 is just a constant. Its derivative is 0. So this is what you should get. We want to write this expression in terms of finding the slope. And remember, this derivative here, this dy dx expression, is what's going to tell us the slope. That's the change in y over the change in x. So I want to solve this expression for dy dx. To do that, I'm going to move these the terms that don't have dy dx to the right side of my equation first. So I'm going to subtract 2x and subtract y over to the other side. And what that'll leave me with is x plus dy dx plus 2y dy dx is equal to negative 2x minus y. All right. Oh, no, did I say x plus? That's x times dy dx. All right, I'm going to go ahead and clear this work over here too while I'm at it so that we can start writing over there. All right, so this is x times dy dx plus 2y dx equals negative 2x minus y. Now again, I want to get dy dx by itself, so in order to do that, I'm going to factor it out of these two. So my next line will be dy dx times x plus 2y equals negative 2x minus y. And then last step, to get dy dx by itself here, I need to get rid of this, the other factor, or the expression here that I factored out of. And so to do that, I'm going to divide. So you'll get dy dx is negative 2x minus y over x plus 2y. Final answer. And for this problem, you would get 3 points. 2 points for getting the correct derivative here for this first line. Oh, that again. 2 points. No, not that one. That one. 2 points for getting the correct derivative here. And then you'll get 1 point for then, I believe, solving it for dy dx. Let me keep. Yeah, 1 point is for correctly solving it for negative 2x minus y over x plus 2y. So that's how you do that problem. The key again is to write an expression for slope at any point. To find slope at a point, we take the derivative. To take the derivative of a function that has y in it, when you're taking it with respect to x, it's the same thing you would do with x, except at the very end you have to tack on dy dx. So mechanically, that's really not that much more different or difficult than when you're taking derivatives with respect to x. All right, number 3. For number 3, we're asked to find, okay, so they give us a whole bunch of information here, but the key part that you have to do for this problem is if g to the negative 1 power is the inverse of g, we need to write an equation for the line tangent to the graph of the inverse of g at x equals 2. So in order to write an equation of a tangent line, we need to do 2 things. We need to find slope and a point. So to find slope at a point, how do we do that? We take the derivative. Ooh, exclamation mark. Woo. In order to find the point xy, right, we just plug in. They give us the x, they don't give us the y. So the first thing we should do is find what is the inverse at 2 equal to. So again, this is an inverse function. So it takes your outputs and it sends it back to inputs. So I'm looking in my table at my outputs for the value 2 is right here. And I'm saying what input produces that output. My inverse is going to take that output and send it back to that input. So here we could say since g of 1, that input of 1 gives us the output 2, then the inverse of 2 is 1. That takes that output of 2, sends it back to 1. So our point is going to be 2, 1. All right, to find the slope, we need to take the derivative. To take the derivative of an inverse function, we have to, the derivative of our inverse function here is, oh, I always mess up with the, like, my, I don't know, ideal notation for this. So inverse function of g, that's derivative is going to be 1 over the derivative of your regular function at the inverse. So the derivative for us then of the inverse function at 2 is going to be 1 over the derivative of your function at the point where the inverse has 2 plugged in for it. So again, we already know what the inverse of 2 is. The inverse of 2 is 1. So this is just 1 over the derivative at 1. And the derivative at 1 is 5. So this is 1 over 5. So we have our point, we have our slope, and then we could write our equation, again using point-slope form. Y minus 1 equals 1/5 x minus 2. All right, for this problem, you get 3 points. 1 for correctly finding that the inverse of 2 is 1 point. 1 point for finding the derivative is 1/5. And then 1 point for writing your tangent line. So again, this is one where, like, if you forgot the derivative rule for an inverse function as 1 over the derivative of the function at the points at that inverse point, um, you could still get a third of the points on this problem just by finding the point that it goes through and plugging in 2 for our inverse and saying what output or what input produces 2 as an output. So for these FRQs, I always encourage you to write as much as you can on a sheet of paper and see what kind of points you can get off of it. All right, number 4. So for number 4, an equation for the tangent line. So I feel like we should be really good at equation for tangent lines by the end of this review lessons, because it's a big portion of the AP test is to know how to do that. And I mean, if you know how to do that, then you know a lot of your other skills. Like if you know how to find slope at a point, then you know how to do the derivative. And so you end up covering a lot of the material you need. So equation for a tangent line. In order to find that, we need slope and we need a point. For us, they tell us it's at the origin. So that means the point is going to be 0, 0. To find the slope at 0, 0, we take the derivative. Well, so we need to find y prime. So I need to take the derivative of arc sine of x over 2. This is going to be the chain rule. The outside function here is x over 2, and then we have an inside function, or is arc sine, and then the inside function here is x over 2. To find the derivative of arc sine, if you just look at the front page of your, I mean, hopefully you have these memorized, but if you just look at the front page of your AP Calc book, or really, I mean, you can Google it if you don't remember it. But ideally, hopefully, in a month when you're starting to take this test, you have those 30 derivative rules memorized, or sorry, 24 derivative rules memorized. For arc sine of any function u, the derivative of that is going to be u prime, so the derivative of your inside function, times the square root of 1 minus u squared. So for our problem, that's going to be u prime. This is the inside function. U is x over 2. That u prime would then be 1 over 2. So this will be 1 over 2 square root of 1 minus x over 2 squared. And our goal is to find out what that is at 0. So y prime of 0 would be 1/2 over the square root of 1 minus 0 squared over 2 squared, which that is just 0. Square root of 1 is 1. A half divided by 1 is just a half. So our slope is going to be a half. Our point is 0, 0. We then write our tangent line in point slope form. Y minus 0 equals 1/2 x minus 0. Now you'll notice that that doesn't match any of these over here. There's no a half, but we can convert this to look like that by simply multiplying the whole thing by 2 to get 2y equals x. Again, it doesn't match. It looks like all of these are equal to 0, so that means I'm going to move the 2y over. So all of this could be equal to 0 too. And then we'll see that the answer there is A. And you could keep manipulating your equation to match. So it's like, let's say you subtracted x and you notice it doesn't match over there, but it's really close to this first one. We'll just multiply it by a negative and you'll get the right answer. All right, last one. Consider the differential equation dy over dx is 2x minus y. Find the second derivative d squared y over dx squared in terms of x and y. Determine the concavity of all solution curves for the given differential equation. Quadrant 2, give a reason for your answer. Okay, don't let the second part of this question intimidate you when you're doing your test. We are asked to find another derivative. That's what we're asked to find. We're given a derivative, we're asked to find the second derivative. So I'm going to take the derivative of dy dx equals 2x minus y. And again, just like we were doing on those problems earlier, we're just going to work left to right. The derivative of y over dy, or the derivative of dy over dx is just d squared on the top and then dx squared on the bottom. See, which is, notice the same notation they use. The derivative of 2x is just 2. The derivative of negative y is negative 1 dy dx. Remember, since we're taking the derivative of y with respect to x, we don't get that dx over dx, that cancels out. We get dy over dx. All right, so that's the first step. Now this is not in terms of x and y. Well, how could we fix that? Well, we know dy dx is 2x minus y. So instead of dy dx here, I could write instead, if I want it in terms of x and y, 2x minus y. So this becomes 2 minus 1 times 2x minus y, or simply 2 minus 2x plus y. All right, that is our second derivative, and this problem is done. D squared y over dx squared is 2 minus 2x plus y. All right, first part's done. Second part, determine the concavity. So remember, the concavity depends on the sign that you get at a point. So if you plug in a point and it's positive, it's concave up. If you plug in a point and it's negative, it's concave down. So for us, we need to find in quadrant 2, are the answers to this problem going to be positive or negative? Well, quadrant 2, okay, let's draw a little picture here. Quadrant 2 is this one. In quadrant 2, x is less than 0, or negative, and y is greater than 0, or positive. So if we do a little bit of number theory thinking about this, if I have a positive number minus 2 times a negative number plus a positive number, we have a negative times a negative is positive, plus a positive. So I've got a positive plus a positive plus a positive, which means that this answer will be greater than 0 in quadrant 2 for any point, right? Because if x is negative, then negative 2 times negative x is going to become positive, and y is positive. It's impossible for this not to be positive. So since the derivative is greater than 0, it's greater than 0 in quadrant 2, it is concave up for all points in in quadrant 2. All right, hopefully that makes sense to you. If you have any questions, remember we have office hours on Thursday or Friday from 9:30 to 10:30, and any hour could show up for those. So you could stop by and ask me a question. Or if you would rather, you can send me an email and I'll answer that. Um, Thank you all for watching, and on Wednesday, we'll move on to Unit 4 review.